Hello everyone, my name is Luke Gecko and I'm currently a CC student and currently I'm in second year. So without any further introduction, I will just get right into the point. So today in this video, you're going to learn how we can implement an equation in a graph using Python language. Now our in-game is going to look something like in this picture. Like here, as you can see that this is a graph and the equation here is like this. So we have implemented this equation in a graph using Python. This isn't just old school robot getting caught type of graph. Now I will teach you how you can implement any kind of equation in a graph step by step. Just stay tuned. So before starting how to implement an equation in the graph, it would be great if we start by learning some basic about graph first. So as we know that a graph can be like this. If we are just thinking of 2D graph for the moment, we're not getting into the 3D graph. But anyway, a graph can have straight line, it can have a wiggly type of line, it also can have this type of line. So this line can represent x squared, the straight line can have some another equation to it. Like this, all kind of line that we can get in a graph has an unique equations. For example, a parabola can have ax squared plus bx plus c square, just like this. So now, for example, let's say we have an equation fx is equal to, let's say, 3.1 into x. Now, for every value of x, we are going to get an unique value. Let's say if the x value is 0, then we will get value 0 here as well. If we put 1 here, then we are gonna have 3.1. If we have 2 here, we're gonna get 6.2. So like this, we are going to have different type of values for every respected value of x. Now it's also true for like 2.001, like for very small value as well, we're gonna get an unique value. Now here in this graph, for every value of x, for starting from 0 to, let's say here, let's say 5, we will have an unique value in this side which will be represented in y. And if we match that one, let's say here's 1, this is 1, the else goes here, and this is 3.1, this is 3.1, this will goes here. So now this point is also a valid graph, like the graph will go from there. So this is how the graph is implemented of an equation. Now let's implement this equation in a graph using Python. But before that, we need to have Python installed in our PC, or and we need to have two mandatory library or very essential library to actually plot the equation. And how do you know that if you have the how to install the library? So simply you have to search cmd, you have to insert in the command prompt, then you have to write pip install numpy and matplotlib. Now these two library is essential to plot the equation in the graph. Now if you see something like requirement already satisfied, that means you already having this numpy and matplotlib library installed in your PC. And if you don't have these two libraries installed in your PC, then it will automatically start installing. And do not close the window, do not close the CMD window unless it is installed totally. So now after installing Python, numpy and matplotlib library, you are good to go to plot something like this. Now let's start code by code. Let's say for equation, so we can start by an example of robber getting caught, or a robber getting caught by a police example. Let me show how. This is a graph of time and distance. Let's say robber is running away with the velocity of 3.5, velocity of 3.5. So his distance would be 3.5 into t, as we know that the distance is equivalent to the product of time and velocity. Then another police, let's say this is the robber R. The police is trying to catch him with the velocity of 4 into t. Now, the sad thing is that the police started running after, let's say, 10 seconds. So after 10 seconds, the police will start running from here. Now he obviously want to catch the thief. Now let's in which point or in which distance the robber is going to be caught by the police. If we want to implement this incident, we can actually calculate the distance of when the robber is going to get caught by the police. If we do the simple equation like the distance is going to be equal at that time, so 3.5 t into 4t, sorry, 4t minus 10, as the police started like 10 seconds later. Then we can calculate the value of t, which is 20. So at 20 seconds the robber is going to be caught. So at that moment the distance is going to be 3.5. We can actually put this 20 value in any occasion, in 4 or 3.5, whatever is your wish. We need to import. So I'm going to write code line by line, and while doing so I will explain everything. You don't have to worry. Import numpy. So now what this two line does is that this, as we install the library in our PC, the numpy library and matplotlib library, and by importing means we are importing this install library to this file because we're not gonna use them. So after that our graph will look kind of like this, where t is going to be in this x side and s is going to be in y side, and s representing distance and t representing time. Now we have to create an time space. You have to create an, I will explain what this line mean in just a few seconds. So now what this line means, t equal to np lin space 0, 100, 1000. This line actually means that we are creating a line which have value from starting from 0 to 100, 0 to 100, and this 1000 means that we are dividing this distance in 1000 smaller parts, so that if this line, this is all not always going to be a line, this is not always going to be a line, it can be a curve, or it can be a parabola, or it can be anything, right? So now if it's only a straight line we cannot make a parabola, so that is why we are dividing this line 1000 times so that it can stretch, it can stretch. If you can actually understand it with an example, you cannot bend and straight stick. If you think like that, you cannot bend and straight stick, or you cannot bend your pen. But if you divide your pen into like 100 parts and attach them, now you can bend them in any way you like. You can bend them in S shape, U shape, but when your pen is straight, or in your stick is straight, you cannot bend it because it's in one piece. So this is what this line means. It creating a limit from 0 to 100, a line with the limit starting from 0 to 100, and it's dividing it by 1000. So after that, it's time to write down our equation. So the first equation, or the robber was running at 3.5 velocity. So now hit robber crossing distance would be 3.5 into t. Now why t? I will write why I have taken link space on t in just a few seconds, and the police is running at the velocity of 4 into t, right? Now this is time to create the plot, like this type of plot, and to do that we have to write figure, and this is the name of the plot. You can give any name you want. You can give your name like noob gecko. You can give your name anything. I'm just going to give a, and then we are gonna import the plot or call the plot from the library imported. Like this matplot library has this function or this module. Then we are simply going to plot this equation. Now, as I said, a is the name of the plot, so a dot plot. First of all, you have to write t, then the equation, and finally the color. Like the color I want my graph to be. Like this line, what color I want this graph color. You can give any color. I'm just going to give red here, for example. Then I have to plot the police graph as well. So I can just duplicate the line, and in place of robot I'm going to give police because I have to plot the police equation as well. I just give green. Now if I plot it, boom. Also there was a mistake. What mistake was this? Because I did not subtract the time when the police started. Like police started after 10 seconds, so I have to give her minus 10. Otherwise the police would have caught the thief in the 0 second, which we don't want that. Which we don't want. We want the police to be a little bit late, but later on caught the robber. So now, as we can see in the graph, as we can see in the graph, if we zoom, we see that this is where they intersect. Like in this point, they intersect. That means this is the point where the police and the thief had met, and the police had caught the thief. So now let's actually prove that we know that by the solving equation actually plan this via add out ax v line. I will tell what is add x v line create. Let's give x value as what, 20 seconds, and color is light. Here any color you can give. Then this is line style. Now if we zoom into the graph, as we can see that it has intersected the point where the police has caught the thief. That means that our graph is correct, like this graph. And we calculated that the at time 20 and the distance 70 the police had caught the robber. Now we can add some more other things. So now, as I mentioned, this what is this x v line doing? Like these are literally creating this dot dot line. The dot dot line we're seeing right here is created by this line. Is telling that create a line at x, create a line at x where x is equal to 20. The color should be light gray and the line style should be like this, minus minus, or you can give color like this. It will still work, but I just find it very beautiful. And for the y axis we need each line, and then where y is going to be 70 and color is going to be light gray and light style is this. And by doing so we're gonna get a line at y-axis at this point. So this two line intersect at the point where the police caught the robber. Now this is how we implement this equation, like the equation that we saw earlier in a graph. We can add some more other things. More other interesting thing, let's say if I want to give label to this graph, we can give title to this graph by some simple function. We can also give the name of this axis, the name of this y-axis by some simple function. Let's the this we have to write the figure name, which is a, then set title, set underline title, set title. You can give any name. Let's say just getting caught. As you can see, the name of the graph change. Now we can also set x name or x label. A dot set x level. We can say here the x representing time, so we are going to write time. And also we can set y level. Y is representing what, distance. So that's how we can plot and graph. We can also limit, like for example here the y is getting up to 400. We can also limit that by setting the limit of the figure a. So x, we can also limit the x limit, set x lim. So x lim stand for x limit. We can let's limit this from 0 to 10, and also set the y limit to 0 to 100, because as the thing getting caught at 60 meter. So now the thief getting caught at 20 seconds, so we can actually, we don't need to give 100 limit, we can give 25 and still you can see the graph very clearly, as you can see. So we get the graph. Now from the equation we get this graph. We also get at which point the thief got caught. Now, what's the benefit of this graph? We can actually see what's happening behind the scene. It's really good to imagine things and anticipate what the things are happening here, like how the graph is working. And this method of implementing an equation in a graph works for others equation as well. Like you can actually implement any kind of equation in this matplotlib. For example, here if I just do another thing, and if I just copy paste this code, then we just have to simply remove these two equation. Let's say I want to implement the graph of the x square. As we know that the x square graph is just a simple line that goes up like this. Let's say y equal to x time 2, right? And I need to plot only one equation, which is x and y. I can actually level this all. I can remove this all, and I don't need this as well here. Alright, as you can see that this this equation x square is also plotted inside this graph using the same method. Here we are simply just creating an linspace. This is the linspace from 0 up to 100, but as we said limit is 25, it's showing 25. But anyway, this linspace is inputting values here up is from 0 to 25, and for that corresponding value we are getting a value of y, and that y is getting graphed here. As you can see, you can actually work with that any kind of equation. For example, x plus 3, whatever way. I mean, it won't change many things. You've got to work with it, you can play with it. You can, that's how we can do or implement any kind of equation in the graph. You can implement any kind of equation in graph using Python, numpy and matplotlib library. So now it's very easy and very effective if you want to visualize an equation. For example, you came across an equation and you don't know the graph of that. You can simply just write down this code and implement that equation on the graph, and you can see it for yourself, like what the graph is doing and how it's moving, what curvature it's making, etc., etc. So that's all about this video.